All right, here's my video answer key for the Chapter 2 closure problems. Here we go. Up here, Chucky and Angelica were reviewing equations of parabolas for their upcoming math test. Help them write an equation for a parabola that opens upward from its vertex at -4, 3. What's the equation of its line of symmetry? So if it's a parabola, it's going to be y equals x minus h squared plus k. And if it opens upward here, then I need a positive number for the a value, which goes in front. So I need to make this number any positive number. So I can do anything. It could be a 1, it could be a 2, it could be a 10, any positive number. So that's good. And then the vertex, h is -4 and k is 3. So I'm going to change this to x minus -4 on the inside, and then plus k is 3. So the way that I can more easily write this is as y equals x plus 4 squared plus 3. Sorry, I forgot the square right there. Okay, so y equals x plus 4 squared plus 3 with a stretch factor of 1, 2, 3, any positive number. And then the equation of its line of symmetry. So for any parabola, if I draw a parabola like over here, the line of symmetry always goes right down the center of it. And the line of symmetry is always going to be, so if this is h comma k, the line of symmetry is always going to be equal to the x coordinate of the vertex. So the line of symmetry for this, so line of symmetry, is going to be at x equals -4. That will be the line of symmetry for that parabola. All right, let's keep going. Question B. Chucky wants the same parabola to open down, and Angelica wants it to be compressed. Show them how to change your original equation to meet both of their desires. So if it's going to open down, I need a negative number. So negative number for stretch factor. And if it's going to be compressed, I need a fraction for the stretch factor. So I'm just going to change it to like y equals -1/2 x plus 4 squared plus 3. And the only change that I'm making is here to the stretch factor. So that now flips it upside down and it compresses it. All right, let's go to question C. Oh, and my bad, does the line of symmetry change? No, it does not. Because the parabola wasn't actually shifted, it was just flipped upside down. Okay, question C. Move your parabola from part B 7 units to the right and 8 units down and stretch it vertically so that it's thinner than the original parabola. So this means that the coordinates of the locator point are going to go from -4, 3, which were the original points, and now it's going to move 7 units to the right. So I'm going to add 7 units to the -4, and -4 plus 7 is now +3. Okay, and then I'm going to go 8 units down. So I'm going to subtract 8. So the 7 units to the right means like adding 7 to the x coordinate of the locator point. And now I'm going to subtract 8 units from the y coordinate. So 3 minus 8 is -5. So these are the new locator points. And then I want to stretch it vertically so that it's thinner. So this means I need to increase the stretch factor. So let's go to like 2 times x minus 3 squared minus 5. Okay? So this makes it thinner, by adding a stretch factor. All right, and then it says, what is the equation of its line of symmetry? So for that point, the line of symmetry is going to be at x equals the horizontal coordinate of the locator point. So x equals 3, and that's coming from that number right there. If I wanted to like graph this new parabola off on the side, I'd go 3 in the x and then -5. So it'd be like right here, the locator point would be here. And so it would be and I'm seeing this right now. It says from part B. So actually I'm going to add a negative in front of this 2 because it still needs to be opened down. So I want it to now be thinner, something like this. And the line of symmetry is going to go right down the center of that. So that's the x equals 3 line. Okay. Moving on to the next question, number 171. For each equation, give the locator point and the equation for any asymptotes, and then sketch the graph. Okay, so locator here is going to be at the 2 and the -1, but it's going to be at -2, -1, because the general form of the equation is always x minus h plus k. So in this case, h is equal to -2. Locator here is going to be at, this is like x minus 0 plus 2, so this is going to be at 0, 2. The locator here, this is like x minus -5 on the bottom. So the locator is going to be at -5, -2. And then the locator here is going to be at, this is like negative x minus 0 cubed plus 5. So the locator here is going to be at 0, 5. All right, this one is an absolute value graph because I see this, this line here and this line here. And so the absolute value graphs are going to look like this. My locator is at -2, -1, so like here, -2, -1. And then notice that we have a negative stretch factor, so it's going to flip it upside down, and this one's going to look like this. Let me fix that. Absolute value shape upside down. This one over here, part B, is going to have a locator at 0, 2, so that's here. 0, 2. But then this is an inverse graph. So it's going to have these asymptotes, these lines, so these are asymptotes, right? These lines on the graph that the graph values approach but never reach. And so the classic inverse shape is the double curve here and here. This asymptote is going to be at y equals 2. It's the definition or the equation for this line here. This is the y equals 2 line. And then there's this other line here where the other asymptote is, and that line is going to be at x equals 0 line. All right, let's go to part C. So we're going to have another inverse graph, but now the locator is at -5, -2, so like over here. So we got -5, -2. And we're going to use the same asymptotes, a vertical one and a horizontal one. This line is going to be at y equals -2. And this other line, this one here, is at x equals -5. And then I'm just going to take those the double curve, and put one here and then one here. So this is also inverse. Okay, lastly, part D, this one is cubic. I can see the cubed right there. And I'm also going to notice that it has a negative in front for its stretch factor, so it's going to be upside down. So the locator, I already defined, is at 0, 5. So 1, 2, 3, 4, 5, somewhere up here, 0, 5. And then a typical cubic looks like this, but we want to make it upside down, so we're going to flip it to like this, and then we're going to move it. So it's going to end up looking like this, right through that locator point. All right, last problem on page 1. We got a Gloria the Grasshopper problem. Gloria the Grasshopper is working on her hops. She's trying to jump as high and far as she can. Her best jump so far was 28 centimeters long and reached a height of 20 centimeters. Sketch a graph and write an equation of the parabola that describes the path of her jump. You must solve for the stretch factor A. So we're going to begin by drawing, a picture. Anytime something is jumping through the air or flying through the air, it will form an upside down parabola. So it's going to look like this. So the start of the jump is here, the end of the jump is here. And from the description, it says the jump was 28 centimeters long. So this is 28 centimeters from here to here. And it reached a height of 20 centimeters. So that means at the highest point here, this distance is 20 centimeters. So now I can come up with locations for these 3 points. I'm going to call this my origin, 0, 0. This point over here would be 28, 0. And then this middle point, it's halfway along the distance. So halfway to 28 would be 14. And then it's 20 centimeters high. So the vertex is at 14, 20. Okay, since it is an upside down parabola, I'm going to use y equals a times x minus h squared plus k to help me figure this out. And I'm going to use this point and these 2 points to help me get information about the parabola. So I'm going to use the landing point as my x and my y. So this is going to be like my x and my y. And the vertex I'm going to use as my h and k. So this point here is my h, and this is my k. So let's go ahead and plug those in. So y was 0, so I'm going to say 0 equals a times x was 28. And you know what? Let me actually spell this out a little bit more. So I have from the landing point, x equals 28. I have y equals 0. And then I have h equals 14. And I have k equals 20. And a, I don't know. That's why it said that I must solve for the stretch factor a. So I'm going to solve for that. So I feel like I need a little bit more room here, so I'm going to add a page. I'm going to go back to that problem. And here we go. I'm going to plug them in. So I'm going to have 0 equals a times 28 minus 14 squared plus 20. I'm going to solve for a. So first of all, 0 equals a. 28 minus 14 is 14 squared plus 20. Okay, and then this is going to be a times 14 times 14 is, I think, 196, but I'm just going to check myself. Yeah, it's 196 plus 20. Okay, and then I'm going to subtract 20 from both sides. And I'll have negative 20 equals a times 196. And then I will divide both sides by 196. So I'm going to have a equals negative 20 over 196. Those look like they're both even numbers, so I can cut them both in half and say that this is negative 10 over 98, and I think that's as small as that can get. Sorry, I could have divided them both in half again, so negative 5 over 46. Okay, negative 5 over 49 is my stretch factor. Okay, so now I have my stretch factor, and I'm going to write it all out in the final equation. So here we go. Y equals negative 5 over 49 times x minus 14 squared plus 20. And this is my final answer for that problem. Notice that this number is negative, and that's because the parabola is upside down. All right, that's page 1. I'll do page 2 in the next video.